VPN at technophilespodcast.com. I'm David Geisler, and this is the Technophiles Podcast.
And this is actually huge. It took them 5 years to go from 12 to 1, but it was huge.
How do you even do that?
How do you create your 1 and 0?
Yeah.
On this episode, the cast talks about new technologies that allow massive amounts of data to be stored. They also speak about sideways dictionaries, choking black holes, as well as the CarLock. It's time to unwind because this is the Technophiles 325th episode. Hello everyone, welcome to tonight's episode. I am here with the regular cast members, Vee Laabs, Krista-Lee Malone, and Jake Gill. Hello all, how are any of you?
Not all at once. Good, I guess.
I know, well I almost did, I almost spoke to you as a singular.
Yeah.
You know? And then I realized no one's gonna, who's gonna know who is going to know who should speak first. Then I said, well, I'll reverse it and still make it.
Should have all spoken at the same time.
Yeah,
we are fine.
We're great.
Jake, how you doing over there?
I'm good.
Fantastic. All right. Let's see. Tonight we are going to be talking about, Krista-Lee, you have in your notes here data storage.
Yep.
And it's so funny because it's like, tonight we're going to talk about data storage. Sounds like it's not going to be interesting, but it's fascinating.
Yep. I agree.
I was looking over your notes, and I actually, before we really get into it too much, we're obviously going to be talking mostly about data storage in part 2 and part 3 of this episode after we go through our quick stories. But I threw this link into your notes 4 years ago in February, episode 107. Myself and Kyle Harvey did an episode about. I don't want to give it away. Remember this moment.
Okay.
30 minutes.
Yeah,
from now.
I saw that you put it in the notes. I was going to ask.
I just realized I almost gave away some of your narrative, but I was really excited to talk about. But some of the stuff that you've been researching here, we were talking about this even 4 years ago on this show.
Yeah, and I actually tried thinking of a better keyword to describe the show because I do think when you say data storage, it sounds really boring. But
Is
I'm
it okay that I
can't
say
think of anything else?
Stuff,
Yeah.
Yeah.
I noticed on your last newscast you said data. Is it okay that I say data?
I really don't. I think they're both correct.
I think you technically are.
I go back and forth.
Do you ever do the thing where you're in a conversation with someone, you say it one way, they say it another way, and you're like, oh shoot, am I supposed to switch now? Or is it like...
Have I been saying it wrong my whole life?
Stupid if I switch? Did that ever happen to you guys?
I did that too.
Yeah.
I think everybody has one of those moments. It might be a regional thing too, I wonder.
Yeah, I mean, that is part of it. The problem with me with data is then I immediately think data from Star Trek.
Me too!
And that is why I say data, because then I don't make
you separate them.
Yeah, I separate those two things, even though that's totally just an idiosyncrasy with me.
No, that's perfectly fine. Yeah, that's totally fine.
I think my issue with it is when I think of I would never say data mining.
Oh,
I would say
it's data mining.
Yeah.
Yeah. And so I say data. My thing is I tend to think of data when it's the bits and the bytes, and data when it's just research information. I tend to go that route.
This is a linguistics study happening right here.
Wow. we keep moving.
We can dig into that some other time, or a linguist can do that for us.
Yeah.
Tonight we are talking about data storage. But first we're going to do some quick topics here. We have 3 stories that we're going to be talking about, and I think we're going to have Vee, you go first here. You have a black hole story.
Yeah.
And as people are listening to these stories, if they have any inclination to comment or question or correct anything we have to say, they're welcome to tweet us at TechnoPhilesPod. And for this episode specifically, if they want to try to get in, if they want to make sure that we see their tweet, they can use the hashtag TechnoPhiles325. 325.
Right on.
At TechnoPhilesPod. So Vee, why don't we go into your quick story here?
Yeah. So this is from an article on Eureka Alert, which is a really wonderful website that kind of breaks down scientific journals and papers that have been released in the recent times, I guess.
Okay.
Is one way to say it. And they just published an article about a paper released by MIT, NASA's Goddard Space Flight Center, and a few other scientific locations about black holes choking. Back
themselves? I don't
just
know.
kind of choking on whatever they're sucking in.
Yep.
Let me set it up. So on November 11th, 2014, 300 light years away, there is a massive flare scene. A tidal disruption flare.
Okay.
This is when a black hole busts open a star like explodes it, like breaks it down and starts absorbing it. Like that gigantic flare is that signal of like, hey, stuff's going down over here with this black hole. Also, there's a black hole here now. You can see it because it's starting to absorb things.
Oh, right.
Yeah.
You can see it because you're starting to not be able to see it in a way.
Yeah. So after that huge electromagnetic burst of energy, all the scientists and folks with gigantic telescopes trained their sights right on that black hole, and they've been observing it for the past few years. And in this paper, they noticed something pretty interesting, where as dust is falling into this hole, like stardust, it's having these fluctuations of ultraviolet and visual waves, just these bands that kind of ripple out from the black hole, which is a little interesting.
This is something that was observed recently, you're saying? Ish?
It doesn't say how recent. It says that it happened once, and then 32 days later, it happened again. And they were like, that's strange. And what they were able to pull from this is that this black hole had not, I guess, eaten anything in a while. It was kind of like just sitting there doing its own thing. And after this star blew up and was starting to be absorbed by the black hole, it started to choke a little bit, where it was a start and stop process of absorbing debris. Where I guess
it's pretty weird.
Yeah, where normally we kind of think of black holes as just like, oh, it's like a constant swirl of like a drain in a sink of stuff going down it.
When you think about it three-dimensionally, yeah.
Mm-hmm. But apparently, I guess they don't know why yet. They think that it having nothing to eat in a while has something to do with it. But the debris would fall in and just kind of be on the edge of disappearing. It would stop for a moment and then go in. Yeah, it's a little strange. It's a pretty interesting matter. If you want to read more about it, Eureka Alert gets into it and has a few really good quotes from the paper's authors. One of which is Diraj Pasham, who explains pretty well this I don't know, action, this thing that's happening with the black hole.
Do they have any hypotheses about what this could be at all?
Not yet. They just kind of have finally interpreted what's happening with it by observing the what's going on the electromagnetic spectrum and what's being kind of waved out from it.
Yeah, sure.
Yeah. But it's something definitely to look at and keep an eye out for in the future. This is apparently like a pretty lucky sighting of this event, since it doesn't happen too often where they find a black hole that's freshly like eating a star.
Yeah, because you know it is true when you think about, you're kind of taught when you think about a black hole that it's everything's going in, we'll say.
Yeah.
And that's it. There's nothing that doesn't.
Mm-hmm. Yeah. So I don't know.
So why? And so I imagine that that's all happening at the same speed.
There's probably some wild physics going on in there.
Cool. Well, this is eurekalert.org
Yeah.
is the article that you're sourcing right now, and we'll have that link certainly on our website, technophilespodcast.com, in our show notes. Cool. Well, I guess let's keep on moving. Let's keep on moving on here a little bit, huh? Maybe we'll get right to this. I know, Jake, you've got a pretty good story coming up here. Pardon me, so I'll give us a little bit of time. I have a story about what my newscast is going to be it'll come out in a week or two. I'm shooting it later this week. And about a month ago, we were given the opportunity to review a product called CarLock. And it's this thing you plug into your car. CarLock got in touch with us and said, well, whatever, they said, do you want to try one out and see if you like it or not, and maybe talk about it if you like it or whatever. And I said, sure, send it to us. So I've been using it for about a month now, and I'll be, like I said, for the full review, it's kind of exciting to do like an actual product review. But for that, that'll come out in a few weeks on our YouTube page. But it's basically, the broad strokes is, okay, it's GPS for your car, fine. I think the selling point for the CarLock is you plug this thing in. Has anybody ever done like that little progressive fob, like progressive insurance? I think a couple different car companies have this.
Yeah.
You plug the fob into that reader that the mechanics use to check.
Right.
your
Yeah.
car.
The little engine check thing, the scanner.
It stays there all the time. It has 4G. It has its own phone signal built into it, and it has some accelerometers built into it, and it reads information from the vehicle. If
Right.
it's accelerating really fast or whatever. So, pardon me. So the idea here is that you use CarLock to, let's say you have to drive into downtown. Let's say you live out of a city and you drive into a city, for example, and you have to park your car on the street every day for work, for example, right? What CarLock will do is it has a complimentary app, and it will feel if the car is being shaken. It'll feel if it'll through GPS feel if it's being moved, and if you're not doing that, it will send you an alert. Basically, say like, "Hey, your car's being tampered with."
Whoa.
It'll know if it's kind of getting broken into or not, or frankly, like if it's getting towed. It can feel if it's getting towed. If its GPS is moving, but it's not getting diagnostics that the wheels are moving.
Yeah.
That's kind of interesting.
Whoa.
So that's, I think, like the selling point of this product is that you can kind of keep an eye on your car when you can't keep an eye on your car. But what I'm going to talk about a little bit more in the newscast, and what I'll just hint to here, is you can actually put many vehicles into this program, and I think like there's a possibility for a family, a mother and a father of a family, to like keep track of their 4 or 5 cars if they have a large family. You can get driving performance scores on each vehicle. You can track every single foot of where every single car goes. It's been kind of fun. We've been using it like when Leslie goes to work down to Marquette and back. We've been using it casually, and it's interesting. It's pretty stalkery. Like I even put in my show notes here. Finally, you can stalk your car if you really wanted to go for it. You know what I mean?
Yeah.
Like their pitch is keep your car safe, but the truth is it really goes into it.
Yeah, that's a lot of info.
A lot of info. It'll give you retrospective data on if someone took a turn a little too hard, if they accelerated a little too fast. You can set speeding limits. You can say, let me know if the car is going 5 miles over what it's supposed to be. All that kind of stuff. It's a conversation, like I said, for another time. There's a lot of things that I'm going to explore about this product and what it and the implications of what it could do in my newscast. But just off the cuff here, like Jake, okay, you're a new father. 16 years from now, even though all the cars are going to be driving themselves 16 years from now, that aside,
Liliana driving
conceptually, I know she's right. I know, but conceptually, how would you feel about something like this?
I mean, I think it's interesting. To me right now, what I'm thinking about is like, this could be something very intriguing for people who, there's a lot of like rideshare services or, it's like get value out of your car that's just sitting there. So if you are someone that doesn't drive every single day and you rent your car out through some of these third-party, platforms that exist, like this could be a great piece of technology to be like, hey, I want to make sure that people aren't abusing my car or whatever,
Right.
I don't know. That sounds interesting. It does sound kind of stalkery, but.
Well, and the thing is, it can be as stalkery as you want it to be. And what I mean by that is you can just use it as big data, so to speak. You can just say like, what's the general performance of the vehicle? Is it, it'll create its own score level out of 100. 1 month we pulled in like a 97, and one time it was a 96, and then whatever. And it's because a couple turns or speeding or whatever. And or you can watch the car drive down the street. Like I've held the phone and watched the car drive.
Whoa, that's
what
weird.
I mean? Like on the map, so to speak, on the Google Maps. And you can go everywhere in between. You can put many cars on your account. And so I imagine I also thought like, man, wouldn't that be great for like a small business delivery service? What if you had like a flower shop and you had to deliver flowers or something? You just want to keep track of your 6 vehicles.
Yeah.
I don't really think that's what CarLock's designed for, but that technology is interesting.
Yeah.
So we'll keep moving. I'm going to talk a little bit more about it. I'm going to talk about the specifics. There is, there's certain payment plans for different tiers and stuff, and I'll talk all about that on the newscast in my final thoughts on the matter.
Right
but it
on.
isn't. But I will confess here on this show, it gave me some interesting thoughts about what you could do with the technology.
Sure.
So, Jake, why don't we move on over to you? And let's see here. I am checking multiple. I'm checking physical notes in a book, and I'm checking digital notes on Google Drives. I'm just going to hand it to you and let you set up your story.
Sure. So today I want to talk about, it's an article that I found on CNET. It's written by Richard Nieva. Apologies if I got that last name wrong. But talking about something called Sideways Dictionary, which is a new release from a company called Jigsaw, which is kind of a sub-project of Alphabet, Google's other arm. And basically, Alphabet wants to make tech jargon simpler to explain to the masses, people who might not have any idea what some of these things are. And it's highlighting the fact that this show kind of highlights, like, we talk about tech in so many different ways.
Oh, Technophiles, sure.
In our lives. And so, this, regardless of whether or not you're kind of into tech, quote unquote, you should have some idea of what's going on, what these things mean. And so this Sideways Dictionary is kind of hoping to accomplish that in some way, shape, or form. So what happens is Sideways Dictionary was launched by Jigsaw, and they're working with the Washington Post here in a partnership. And it's just an online dictionary with some like analogies and trying to take jargon and put it in terms that normal people might understand. And so,
I mean, is it a thesaurus? Does it translate these things, or do you think it tries to contextualize them?
Well, so I have some examples here of things that I was looking up. But before I get into that, just a few other brief notes from the article and things that I think are kind of interesting. Some of these things that are on here, these analogies and such, are written by Alphabet chairman Eric Schmidt, who's one of the Google guys, and also
one of the Google Xers, the old Google Xers,
Surf, who is one of the fathers of the internet, who now works at Google as the chief internet evangelist. So these people, they want to help people understand things. So I have a couple examples here that I thought were kind of interesting. Machine learning, it's like reading tea leaves, because it's about recognizing patterns in data in order to predict what comes next, except it works.
That's funny. That's actually what it says in the Sideways Dictionary.
And so there's actually a bunch of different examples. If you go in, like, they have some keywords that you can go in. You can query things yourself. And then if there are things that are not already in there, I did notice that it says, like, we're going to record this and take it into consideration of if we should provide an entry. And so people, just checking out the site, like, you can create an account on there. And so you could be a contributor to this kind of dictionary as well. I looked up another one. I remember us doing an episode of talking about like torrenting and things. So I looked up BitTorrent.
Yep.
And it's like photocopying a book. If you have one person and one photocopier, it's a laborious process to copy each page. But if you have many photocopiers and willing helpers, you can tear pages out, copy a few each, and assemble them in a new book pretty quickly.
That's a really good analogy. Whoa.
I love what this thing's trying to do.
Personal favorite here, just digging through a troll.
Oh boy.
It's like playing chess with a pigeon. As old as the old internet meme has it, however good you are at chess, the pigeon will knock over the pieces, crap on the board, and strut around claiming victory. So, I mean,
it's playful,
brilliant.
but it's correct.
It's definitely playful. I think
that.
that Krista-Lee, you, before the show, you kind of had some thoughts when you were poking around as well.
Yeah, actually, so I mean that's hilarious.
There's some super fun ones on there.
And a lot of these I'm looking at, and I already know the word, and so I read this analogy, and I'm like, yes, okay, that makes sense. But then I look at something like, I think what came up is the first thing I had hit was HTTP, and it says, it has this little analogy, but I'm sitting here at this analogy, and I'm thinking, if you are starting at zero knowledge of what HTTP is, I don't think this is going to help.
So what does it say?
It says it's like living in a glass house. With HTTP, you have to bear in mind everything is unencrypted and theoretically open for others to see. That's fine for some activities, but it gets awkward with others. With HTTPS, you can draw the curtains and close the shutters.
That's an okay metaphor, I guess. Yeah.
It would be nice if they had like a little sub tab or something next to HTTP that was like the actual definition and like where it's used.
Yeah, see,
okay, that's what you're talking about.
Like, so like break down the acronym
on like how it works, the metaphor of how it works, but it's not
where
that specific
where
example.
Is it used? Like
right. So that's
isn't explaining what HTTP is.
Yes,
right, and that's what I was kind of thinking. Like, I think that this. I think the way I would use this is I would look up the regular definition, and then I would come to this, and I feel like the two combined would be the best way to get clarity.
Yeah,
sure. Now, Jake, how do regular people or anybody, frankly, find this? Is it just a site that's open to the public? Because I thought I heard you say something about a login.
Well,
Like, do you have to start an account?
No, you can just go on sidewaysdictionary.com is the URL.
Okay.
But if you wanted to be, say, a contributing member, I think that you
There
can
we
create a login and start adding some analogies on there. So yeah, I mean, I don't know.
Ultimately, I think this is a great
new,
thing.
It's interesting. I think people were talking about. I think it's noteworthy that some people in the tech industry, some giants, quite frankly, are like, hey, we need to help people that are not in our industry understand what's going on, and this is kind of a way that they're going about it. So it was one of these things where I think on Technophiles, so often we talk about things that are either coming soon or so out of reach of like things that we can do, like going to the moon for $80 million on SpaceX. Like that's not going to happen. But if you're a listener and you hear something or you want to check this out, like you can go online right now and give it a go and see what you think.
That's true. That's cool. And we'll have a link to it on our website, technophilespodcast.com as well.
I'm going to probably link this to my class, actually.
Yeah.
Yeah.
I think it's
Yeah, I think
cool.
that'll be really helpful.
I actually think so.
There's, I've
good.
definitely looked up a few things on there, and I will. It's getting bookmarked as something to, should I need to look something up, and I want the non-jargon version.
Yeah.
I will be
All that
going to
layman's
Sideways
terms.
Dictionary.
Well, now, like Jake, you work in tech, and I work in tech-ish sometimes when I have clients and stuff with my job, and I often find over the past 10, 15 years of my life that you often have to use metaphors to kind of explain certain things. Like, how do you really explain RAM to someone who has no idea? You have to use like maybe a metaphor of a desk or arms or shelves or drawers and how many arms you have and all that kind of stuff. And there's nothing wrong with that, but this is kind of going in that direction. Do you encounter that as well, Jake? I mean, I guess you kind of, well, I mean, may I ask, do you encounter that kind of stuff as well when you're talking about your work?
Yes, I mean I do. You obviously.
I mean, it's the classic like when
sometimes
you're talking to mom and dad.
you throw
like,
something
Yeah.
out and you
You know what I mean?
They don't get it.
and that's true for any occupation that has a specialty, of course, obviously. You know what I mean? My sister is a nurse, and she'll talk to me about things, and it's just, and I'm like,
Yeah.
you gotta, like, what is that word for that thing? I don't know. And she'll be like, well, it's the thing that squeezes the blood through the thing, and I'm like, oh, okay, now
Yeah.
Right.
Yeah.
okay.
And I think the point here, as I kind of mentioned early on when I was kind of setting things up, is just like, we cannot. If you're not a medical professional, it's okay for you not to understand these things. But if you're interacting with technology every single day and you still don't get it, that can be problematic.
Yeah.
So
Yeah.
this is trying to just, in any way, shape, or form, make it more understandable and accessible to people that are not, quote unquote, in the industry.
I would say at the
And I
very
like that.
least, it's just trying to provide some momentum.
Yep.
As well.
Exactly.
Yeah.
Start
That's cool.
here, and you can kind of build on that knowledge base as you go.
Super awesome.
Yep.
That's great. Well, I think we're going to go to break right now. We're going to come back, Krista-Lee, with your I saw you have a little bit of history in here, which is kind of the norm on the show lately, which I love. And you've got some really pretty impressive future versions of how people are going to be reinterpreting data storage. Maybe not reinterpreting, that might not be the right way to say it, but kind of literally storing things in ways that we may not be expecting.
I'm stoked.
It's very cool.
Yeah.
I have said before on this show plenty of times, technically, as long as you can create a 1 and a 0, you can create data storage. And like I think I said in this season, or maybe it was last season, you can have a bunch of ping pong balls or a bunch of plastic cups on a football field and put ping pong balls in them and move the ping pong ball in and out of cups and technically make a computer and store data that way. If you're creating 1s and 0s, it's highly inefficient and ridiculous. But what I'm saying is I think I'm trying to set some tension here because it looks like, according to your notes, you found some scientists that are finding really interesting ways to store 1s and 0s is the point I'm trying to make. Cool. Well, okay, we'll be back in just a bit. In the meantime, you're welcome to, in the meantime, it's going to be 10 seconds, but you're always welcome to check us out on Facebook. And remember, if you do want to comment about any of the quick stories that we've just spoken about, you can tweet us at TechnophilesPod using the hashtag Technophiles325. I also want to note real quick that if you're listening to this episode on iTunes or Google Play right now, we actually also create a video version of this podcast, and you can go over to YouTube and search Technophiles and subscribe there as well. You're more than welcome to listen to us on your iPod while you're driving to work or riding your bike or at the gym or whatever you're doing. But if you are inclined to watch us, you can find us over at YouTube as well. And
We got a
subscribe
cool
to us.
set.
We got a cool set with a
Yeah.
new dinosaur on the wall.
Yeah, we do.
Very excited about
Very
that.
sweet.
Cool. All right, guys, I'll see you in 10 seconds. Krista-Lee. From TPN at Technophilespodcast.com, I'm David Geisler, and this is the Technophiles Podcast. All right, we are back from the break. I am here with the regular cast members, Vee Laabs, Krista-Lee Malone, and Jake Gill. And Krista-Lee, tonight it is your episode, and you're talking to us all about data storage, as we have mentioned a little bit already on the show. And I'm going to ask why you wanted to talk about this, because I have come to learn that that's a good question to ask right off the bat, because I'm always kind of curious. You know, it's always interesting, like, well, why did someone want to talk about this? So after that, I'm going to let you just go. But why did you? What captivated you about data storage?
So actually what happened is I found an article, which I think was from last week when this episode is probably going to come out. And it was about storing information on atoms, which originally I thought I'm going to pocket this for a quick story. But then, because I didn't really think about it, and then I was out with Jake before this episode, and he had reminded me, like, I had known about DNA storage before, but I wasn't thinking about it. He reminded me of that, and that's when I suddenly realized, oh no, this is a main topic.
Cool. This happens like a couple days ago or something?
Yeah.
Yeah. That's awesome. That's great.
Mm-hmm. So that's what happened, and that's what brought me here.
You're welcome.
Thank you.
Just kidding.
All right.
No, but yeah, we had a nice talk about it. Now I definitely was like, no, Krista-Lee, this is main topic worthy, and I'm excited to talk about it too.
Excellent. So
thanks for doing the research.
Well, okay. So in the timeline we're going to talk about here is actually going to cover about 2,000 years.
I'm in.
All right. Excellent. That's my little teaser for what we're going to end with. But anyways, so first of all, real quick, the reason I thought that this was important for a main topic and not just a quick story is because without data storage, we don't have anything else. You don't. If you can't save the information, you can't progress, you can't move on, you can't have programs stored on your computer, like nothing. You don't have a computer if you cannot store the software that runs your computer.
You're absolutely right.
Yeah.
So this is like the backbone.
With that statement, I'm forced to ask you, your interpretation of data in this episode is essentially storing ones and zeros, or is it like writing a book? We've stored data. You know what I mean?
Yeah, I do know what you mean. So the thought had crossed my mind of I could go all the way back to writing, but then this show would be way too long.
Right.
So
I'm pleased that it sounds like maybe you didn't.
Yeah, I didn't.
Technically, communication was data. You know, like, but I
Right,
think data is like when you
It's very inefficient.
Yeah.
Right. So we're definitely talking ones and zeros here.
Okay.
Not even though, like, technically speaking, if this was like a history show, I would have gone back that far.
Yep. Cool.
But no. But even with that, like I do mention, and I guess this would actually go back to the writing thing, like we lose knowledge all the time.
Yeah.
And the only reason we even know that we do that is because every once in a while an archaeologist digs something up and they're like, oh, hey, look at that. How did that happen? And I think the example that I was talking about during break was the Chinese puzzle ball.
Let's talk about that.
It's made out of jade. It was carved out of a solid piece, but the pieces inside are movable. And I saw this when I was at the National Museum in Taiwan, and it's like amazing. And nobody can figure out how it was made.
Because when you look at it, it seems like carving and etching was happening inside.
Yeah,
it's like detailed. All the way
there's
down.
no seams or anything. Like
I remember
impossible.
when I was a little kid, my grandpa carved a wooden link of chains out of a branch, right? And it blew my mind as a kid because I thought, how did he carve each one of those?
And then
link them.
Yeah.
Well, of course, he carved it in a special way so that you're carving the links as you go.
Yeah.
I imagine this is that. What, times a million, as they say, right?
Well, I mean, you think about it. So your grandfather had the knowledge of how to do that, right? I'm talking about a thing that experts cannot figure out how they did.
Can you explain to
this.
me personally a little bit more what this sphere is? Like, is it similar to this chain link kind of? Is it similar to that?
I mean,
is it a puzzle?
Times like 1,000 in complexity here, because it's like you have a sphere. Inside of a sphere, inside of a sphere, inside of a sphere,
and they all rotate.
They all rotate and move around.
Okay.
But because they can't find seams anywhere, it must have been carved from a single
Right.
piece of jade.
Yep.
And it's ancient, right? So we're not talking about like, hey, sure, with some lasers, pew, 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 and then it's done,
Sure.
right?
No.
This is...
Or for example, by today's quick thing would be you 3D print it and you can print all these quote unquote impossible objects because you can
Right, because you
Print
it
the thing inside
from
it.
scratch.
These
Right.
experts just need to get off of Facebook and apply themselves a little to do it.
All right, cool.
Right. So the other thing, and this is now we'll jump to a little more techie. We as humans want to archive everything, and that's not necessarily a bad thing, right? Because like I said, then you don't, if there's something that people forget how to do, and we've archived the knowledge, you can go to the archives, read it, and be like, okay, here's how you do it, right?
Everything might be important later.
Right, exactly. You never know. And now think about how much data we're generating, right? We talk about space probes and exploration all the time here, right? And then in the like Memics topic from, oh my God, maybe a year ago,
Yep.
all of they were having trouble just getting the data back to the NASA scientists, right? Now, we're not talking about storage now, just getting all of that back.
Can you set
right?
that up a little bit more?
Right. So Memics was basically a way to, it's like the Google for the deep web.
Right.
That's the simplest way to put it. Is definitely the Google of the deep web. So then you can.
I think you said at the time that the regular web is only about 15% of the actual web. The regular web that people just access when they're Googling and finding
Right.
websites and stuff. That's
Right.
like 15%
So
of what's really going on.
This basically allows you to find the other things because Google goes off of keywords and whatnot. If
Yeah.
the thing doesn't have any keywords or anything to look for, then Google can't find it.
Yep. Okay.
Okay. So now, just to put this a little bit into perspective, it's estimated that by 2020 there will be 44 trillion gigabytes of data,
Yeah,
from the internet that people are going to be trying to archive.
Logged, library. Okay. Archive,
Yeah.
of course. Right. Yeah.
Right.
Jeez.
And
As a lot.
44 trillion gigabytes.
That's
yeah.
bonkers.
And here's the thing. Like, think about if you have like, I don't know how big my storage is on this computer actually, but like my desktop at home is 1 terabyte, right?
Sure.
And now think of the size of that. Now imagine, right? You have 44 trillion gigabytes, the actual space.
Like where? Yeah.
Of where
storing
you are,
something.
Yeah.
where are you going to store this thing? And then a lot
Jeez.
of storage also requires certain environmental conditions, right? You
like
can't just
server bases that are in
Yeah.
like colder parts
right.
of
You
the country.
can't let them
Computers
overheat
somewhere.
or get
Yeah.
rained on.
One of my favorite joke quotes about cloud technology is it was like a T-shirt or something, and it was like, "The cloud, it's just someone else's computer."
Yeah, that's actually a great way of explaining it. Yeah.
Yeah, put that on
Like, we
Sideways
don't have these-
Dictionary.
we don't have these magical places that data goes. It still
Right.
has to sit somewhere.
Yeah.
Right. So this is why this is all important. And then later at the end of the show, I want to like kind of come full circle. And this is why I said we're going to cover 2,000 years because I'm going to talk about how these advances have made certain preservation efforts possible. And the example I wanted to use was the Dead Sea Scrolls, because this is data storage and it's written. Now we're digitally storing it and also preserving the artifact itself. So there's a lot of levels going
Love
on.
it.
Layers.
Cool.
All right, so brief history. And I'm going to tell you right now, there's going to be a lot of jumps in here because, again, not a history show. So, yes, we know I'm skipping a lot.
We're
But-
contextualizing it.
Yes.
Yes. So I started with punch cards from 1725 that stored programs to automate looms. Basically, you take the punch card.
What?
You could stick it in the loom, and then it would tell the loom to make that particular pattern, and you could change out different punch cards to make different patterns.
I didn't know looms could do that.
Yes.
Whoa.
And so the reason I started here was, again, because I didn't want to go all the way to written words. And I also skipped things that I felt fell into the mechanical model.
Right.
So like some of the robot examples, like there's one from the 1200s where it had the pegs, but because the pegs physically came out, I felt that was more mechanical.
I agree.
And so I skipped that.
Well, for example, another thing to skip would be like a a template. Like if let's say there was to make a rug or a way to weave. Maybe there was a physical template you just push down. You put down to cue yourself.
Yeah.
Well, that's a 1-to-1.
Yeah.
Right.
This is something where the information is being translated to a different style of information.
Correct.
Yeah, it's
And
like
I think that's
symbolic.
important to point out.
Yeah.
Right. So that's kind of I wanted to contextualize why I started in the year 1725 and why with punch cards. And so that was why.
Cool.
Now we're going to jump to 1947. Like I said, big jumps. 1947 was the Williams Kilburn tube. It was very similar to the cathode ray tube. This was how TVs worked back in the day before they were flat screen. And I also, when I could, I found out the actual size just because I found this interesting. This tube could handle a whopping 62 bits.
Yep. Sure. And the tube being what is some vacuum tube? Like
Yeah, it's similar to that. Like I have a picture of it, but there's nothing in the picture to show you the size.
16 bits too, not bytes.
Yeah, 62.
62 bits.
Yes,
Got it.
it's 1/16 of a kilobyte. Yeah,
Cool.
This was storage.
Yeah, pretty exciting at the time.
Wow.
All right. And then 1950, this is a smaller jump. And the reason why is because this is when they started going with magnetic memory. And this is going to carry through for quite a while. The magnetic drum memory, which used ferromagnetic material. And this is like I said, first magnetic precursor to the modern hard drive. Just to break that down a little bit, ferromagnetic just means a substance with high susceptibility to magnetization. And it's the strongest type of magnetism because there's, I think, 4 different types. And this could store a whopping 10 kilobytes.
10 kilobytes.
Yes.
And so instead of holes with pegs and things like that, you're polarizing it one way or another, or polarizing it or not polarizing little pieces of this drum, and then you can read that back.
Yeah, pretty much.
That's how the data is being stored.
Yes. Okay. So then through the 50s, you see almost all having to do with magnetism in some way or another, but you see magnetic tape memory, the first magnetic core memory, also the first reliable RAM, which is random access memory. And a lot of these technologies were still used up through the 70s.
Magnets worked fine for a long time.
Yeah.
They did.
And they still do, really. Just, size.
Yeah.
Became the big thing. Like a lot of these earlier
Unwieldy.
examples too. Like maybe actually it might be this next one I'm looking at. Some of these, some pictures I pulled from Mashable, they will have like an adult human standing next to it to judge the size, and it like is coming up to somebody's waist or chest.
Yeah.
And it's like, this could store, your 10 kilobytes. It's like,
Oh, man.
God. Right.
Yeah, those are some of the most fascinating things to look at. Like,
Yeah.
Yeah.
When computers were entire rooms and stuff like that.
yeah.
1950s is also when we sorry.
No, it's fine. I pulled up a picture a little too early here, I think.
No, I just
I was like,
tripped
oh,
over
clearly
my
we're going
tongue.
to the disk magnetic drive. I pulled it up, but we're still in 50s.
So sorry, I'm trying to. No, because the only other thing I wanted to mention about the 50s was 56 was the first hard disk drive. And the reason I wanted to mention it is because we finally got to the point where we could, instead of working in kilobytes, we could work in megabytes. And so 4.4 megabytes. Throughout the 60s, you still have basically a lot of either disk or magnetic things. So microtape comes up, cartridges. I mean, I remember we were still using cartridge type technology. We were kids, right? With video games and stuff. Those things came on cartridges.
You sound skeptical.
Yeah, you sounded real skeptical,
I
though.
think those cartridges work, not that technology. We haven't talked about that tech. I think that's a little bit different, but yeah, cartridges in general, yeah.
Yeah, I mean, I was trying to kind of gloss over the 60s with the idea of on tapes, whether it's microtape or not, cartridges, discs, I mean, that whole idea of a disc coming in. And the other thing is these were all, the important thing here is these were personal storage options, right? So now we're moving from, the big thing that's sitting on the floor to I can hold this in my hand and carry it.
It's not a room anymore.
Right.
Yeah.
Right. 1970 was the first computer to use semiconductor memory with flat electronic circuits made of electrically conducive crystals or other materials.
This is getting closer to those
chips.
cartridges, but anyway, the video game ones.
And this took half the space of previous technologies.
There you go, getting smaller.
Yep. Yeah, I mean the whole this all goes to you just get smaller and smaller with every decade going down, basically. 1970s. I'm going to kind of jump a little bit, but you have data cell drive by IBM. You have more magnetic strips. Magnetic strips around a rotating cylinder could hold 400 megabytes. This was also the time of the first floppy disk. This was 5 1/4.
Yeah.
Again, for personal use, and this could hold 1.2 megabytes. In 78, laser discs came out, which I didn't know that laser discs were that old.
Yeah, I see. That's interesting.
Yeah.
And these, of course, are basically the forefather of CDs and DVDs, laser discs.
And it's important to note that the Laserdisc is the first time, well, not the first time, but at least in our history here, as you're telling this, it's all been magnetically stored so far. So it's polarized or not, or it's polarized one way or the other. And that's how and that fidelity has been increasing. They've been getting better and better at the fuzziness has been going away. So they've been able to make the literal space that holds these polarized areas smaller and smaller, and that's what you've been talking about. But a laser disc records the ones and zeros by having light reflect one direction or not. So the laser literally does hit the disc.
Right.
It's not it's not magnetic anymore.
Right.
It's optical.
Right.
Yep.
Unfortunately, it was also too expensive to ever take hold. So that's why.
Yeah.
Yeah.
I mean,
I wonder why. I know, like, when Laserdisc finally really tried to be public in the 90s, it was just they just couldn't get enough data on the disc. It was the size of a record. You could only put an hour of video on there and stuff like that.
Yeah.
Yeah. Well, I mean, think about it. I mean, how much would you really pay for something that can only hold that much? I mean, I think we had one in my elementary school, and like, because I remember seeing a CD that looked the size of a record.
Yeah.
Laserdiscs, yeah, I mean, they were around in the 80s
like,
and the
nobody-
90s.
It just
They
didn't
were
catch on.
hefty.
Right. Nobody had
It
one in
was-
their house.
They're easy to scratch.
Yeah.
They're really expensive.
Right.
I knew a few, like my doctor's
early.
office, my pediatrician's doctor's office had a Laserdisc player, and they
Oh,
played
yeah.
Sesame Street or something, right?
Okay, yeah. So that was just to keep the timeline going. I did mention there that because that was the precursor to CDs, which came out in 1983, and DVDs, which came out in 1995, which was the other thing. I didn't realize DVDs were that new. Like
DVDs?
Yeah.
Like as I was going through
Well-
this, in my memory, some of these numbers.
That
seemed
feels like so
weird.
long ago.
But
at this point now.
DVDs are
true.
kind of new because we had CDs for a long, long time, but it's really once you start getting into the multiple layers, that's where the DVD
Yeah.
stuff starts taking off. Storing data three-dimensionally is what DVDs begin to do.
Do you guys remember what a CD could hold? Like, it was like what, 800
Megabytes, I think.
megabytes?
Yeah.
You
wasn't
know
a
what? I
gig.
actually don't know.
I don't think it was a full gig.
Yeah, I don't
And
know.
there's a
I was-
difference.
It was like 700. You could get actually different storage
Yes.
sizes,
Yep.
right? And you like paid a premium for like, and then there were like you would have various ones could do different write speeds.
It's true. It's true. And then
Those were the
rewrite-
days,
Then the
guys.
rewrite discs. Did you know? Like, do you remember there was because then there was the burnable discs.
Yeah.
And they physically were changed. You would make a physical change on them, just like scratching a record.
Yeah, yeah.
Conceptually. But then there were also the read-write CD discs. I don't know if the compact discs. I don't know if you recall these.
I've never heard of these.
This is like 10 years ago when I was running a very small little media company, and this was like the hot thing. But it really felt like a bad idea because what it would do is they would basically put little dabs of ink down to microscopically dabs of ink on the disc to make the light reflect or not re-aim the light. So then you could theoretically chemically wipe that and reprogram
Okay.
again.
Whoa.
But it was so soft, we'll say. You get so much broken data because it was so easy to wipe it. It wasn't easy to wipe it with a thumb,
Sure.
but all things considered, it was not as solid as physically a new angle of light, right?
Sure.
Anyway.
So is that still how rewrite discs are made with the ink?
Well, optical ones,
Okay.
not hard drive. That magnetic stuff is different.
Right. No.
Yeah.
But, like I occasionally to this day will
CD-RW or whatever.
will I have one and I will write a CD for somebody.
And then they rewrite over it later, or they don't, or they do.
Well, I don't know. Basically, I've done. I mean, not that it's all that often, but it'll be because every time it's been a MacBook Air or something that
Sure.
doesn't have
CD
USB
drive.
or,
Yeah.
or something.
Yeah.
And so
I
then
think we spoke about this, yeah.
Or no, it's the opposite. No,
Oh.
maybe it's the opposite.
Right, but
Yeah.
well,
anyways.
if you're burning a disk one time, it depends if it's CDR, CD, CDRW.
Yeah.
Usually, all the classic CD burners that we used back in the '90s to burn our awesome playlists of
Right,
8 songs or
right.
whatever,
Yeah.
those were physically getting physically changed by
Right.
lasers scraping angles in, basically. But RW.
Right.
All foiled by one wrong scratch.
Yes,
Yeah.
indeed. And it makes sense, doesn't it?
Yeah.
One wrong scratch throws that laser in a different direction.
Yep. Yep.
Anyway.
All right. Yeah. Anyways, I was just curious since
Yeah.
I still.
Oh, the
occasionally-
good
I
old
understand.
days.
Yeah. fragile data storage.
Oh, man.
So I really have only like 2 more things on the history aspect I want to mention. Flash memory came out in the 80s. Actually, I'm not even sure why I mentioned that now, but there it is. Flash memory came out in the 80s. And then
Was that the first time that we were really doing solid state memory? I don't really know the history of that. Flash memory is solid state, right? It's a chip. am I getting
Commercially, maybe.
Yeah.
So I must have left it out of my notes, but the first solid states before the 80s.
Oh, really?
In a lab, in a company.
Probably in the
but-
70s. When we're starting to get chips.
Yes.
Yeah, that makes sense.
Yeah.
But it's possible that in the 80s is when it became more commercial.
It's possible.
I'm not sure. Sorry that I.
And probably
missed that.
ridiculously expensive.
Oh, yeah.
I mean,
Well,
it
it was-
always was.
sure.
It was
right?
almost in the 80s. Oh, right. I almost said 50 years ago. I had my math all wrong. I was like, wait, no, I put the 20 on the wrong
definitely
side.
not
I was
50.
thinking 30 or 80. Anyway.
Whatever. Anyways.
Yeah. So from the history perspective, I really basically then skipped 1980 to 2000 because not that there weren't a lot of improvements, because there were, but a lot of what I was seeing was just making what we already had better or smaller,
Yes, I agree.
whatever. Nothing majorly
Yep.
great.
Or reducing the cost just because it would be,
right.
you know.
But nothing that was just
was
so novel that I wanted to bring it up.
Yep. I agree.
Makes
In
sense.
the 2000s, though, we have the advent of cloud storage, which is not really new. So this is not new technology, right? This is just
Using it a different way.
right. It's just
Yeah.
using it in a different way. And I only mention it because it will, it'll come up later.
Okay.
And it changes the way that we can use storage for research, for progress, for all of these things.
That's true.
Makes everything easier for sharing and whatnot, because people don't progress in bubbles. They-
Also in the 2000s
do
is
it
when
together.
our internet speeds were fast enough that cloud storage was starting to make sense.
Yeah, well, that's
Yeah.
the other thing, because you
Yeah.
have to have a speed fast enough, because nobody is going to say, I'm going to store this in the cloud. I'll press this button and
And
3
wait.
hours
Yeah.
later,
Yeah, it'll be up
Exactly.
there.
it's up,
Yeah.
right? So yes, internet speed also made that possible. All right, so for these next 2, I'm definitely going to slow down. So the history I wanted to gloss over because history. This next one I wanted to bring up was the DNA storage, right? And this is the one I teased in the beginning. Jake had brought it up over dinner. And I mean, if you really, so the first time I remember hearing about this, I thought that's really weird. But at the same time, if you think about it, I mean, DNA essentially
It's 4 bits.
not only that, but those 4 bits store all of the information that creates an entire complex human being, or
Yeah.
actually anything other living thing.
It's not just
right?
those 4. It's the arrangement of millions of those, but it's only 4 states. Yeah,
Right,
yeah.
exactly. So it actually makes sense, and it's tiny, right?
Yeah, and
because
it's
all
super
of
tiny.
you is stored. All of that information is stored in a
Yes.
single cell,
Yes,
which we
super
can't
tiny.
even see.
Yeah.
Right? That's how small it is.
That's wild.
So there are. So basically,
Oh man, I'm gonna lose that data all the time then.
Every day.
Where did I put it again?
Oh,
floating.
jeez. Oh, jeez. Did anybody see my DNA? Oh, man. Oh, man.
so the,
Sorry.
So
You
the fact
sneeze and it's
that
just like, no. Terabytes.
So the fact that DNA storage is actually DNA storage, the fact that DNA is base 4 actually really helped make this possible, because DNA there's actually several things that will create errors when putting data into DNA, and 2 of them have to do with the base 4 thing, and that is that if you have too many of the same base right next to each other, you can get either errors in the DNA or read errors when they're synthesizing this.
Interesting.
So you don't want that. But then, of course, depending on the data you're trying to store, you might need that. And so one of the things, or one of the ways that this is done is a 1 will be 2 of the base pairs, and a 0 will be 2 of the base pairs, so that they can be alternated if needed.
Just making binary out of
right, exactly
4.
Which then makes it possible. Now, there's a few things with DNA storage. So when I was talking in the beginning about the literal space of trying to archive all of the data, right? Which, I mean, America has these. They have the, what's it called?
Are you talking about server farms? What are you talking about?
Not server farms, like something like the Library of Congress, where they have a copy of all the books. There's also, I can't remember the name of it. I'm so embarrassed.
A place where they have all the data?
Where their archive, like old newsreels and things on electric tapes.
It's one physical place?
I'm talking about? Yeah.
I know what you're talking about. My friend is actually doing a documentary on this, but I can't remember. Oh my God.
Maybe we'll think of it and break. I can't believe I didn't put it in my notes.
So there's
but
one
anyways,
physical place where things are being physically...
Google.
They're not being translated to digital and in one place.
No. I mean,
so it's we'll just call it the Great Library.
But sure, I mean, but the thing is like everything is stored somewhere. Like you said, the cloud earlier, the cloud is just somebody else's computer, right? All data is physically stored somewhere. DNA, if you're looking to archive something, not like save the paper you're turning in next Friday, is great because it's so small. You could archive all of the, 44 billion trillion gigabytes of data and then store it somewhere very easily because it's very small.
Isn't it essentially ROM though? Like can't you own, I think this is what came up 4 years ago on episode 107, is that the DNA idea was really good, but you could only write to it. I don't think you could change the data quickly at the time.
So actually you can't even write it quickly.
Okay. All right, let's learn.
Right. And so that's why I'm specifically using this. Maybe it is just the National
Archives.
It's the National Archives.
Using this archive idea.
Yes.
Yeah.
So, right. So the reason I'm saying great for archival needs, which suggests long-term that we just want this for posterity and not the paper you're going to turn in Friday, is because it takes a very, very long time to synthesize the DNA and write the data to the DNA, and then it takes a very long time to actually read it. This is not a speedy process whatsoever.
Well, right now.
Right now, correct. And so interestingly, I found that this was actually, so the idea actually goes back to the 1960s.
Sure.
There was a Russian scientist who he didn't do it. There was no experiments. It was a hypothetical. He wrote about maybe this is a thing that could be done.
I mean, it makes sense mathematically, but execution, obviously.
And then I actually found that it was first done in 1988.
Wow. But they used frog DNA to fill in the code.
So it was one of these things where, it took forever. It took a ton of money. The scientist basically encoded some book that he wrote, and then nobody really talked about it again because it was just not, it wasn't feasible, right? So it was kind of, here, proof of concept, and then we just let it sit.
Sure.
In 2011 is when it really got picked up again in earnest.
Interesting. 2011. This lines up with our episode 107.
That's what I was just thinking. That's probably what you found for that episode.
And it wasn't my story at the time. I think Kyle brought it. That's why I only kind of half remember it, to be honest.
Sure. Well, this would actually be the point. Do you want to say anything you remember from that episode? I did not know about that until today.
It was a press release that this company was talking about, that they could store data on DNA, and because of it being base 4, it's not just that DNA is so small, it's that there's an exponential mathematical advantage as well because it's base 4, is the thing that they were getting really excited about. And basically in 2011, they were already getting to the point where they could build DNA for other reasons.
Right.
Genome reasons or whatever, genetic reasons, whatever. But they were like, well, wait a second, we don't have to use this to make a baby dinosaur. We can use this to just as a writing system, is really what they were figuring out back in 2011.
Rad.
And I'm hoping, it sounds like over the last couple of years now, something's come up.
So just as, I don't know, a tidbit if anyone's interested. So in 2011, they encoded. I mean, these almost seem kind of random things that they were trying to save. Shakespeare's sonnets, an audio snippet of Martin Luther King's "I Have a Dream" speech, one of the researchers' books.
This is all coming back to me. I remember Kyle talking about Martin Luther King's speech and all that.
There also was somebody encoded. I think it was the King James version of the Bible, but I'm not sure if that was the version. So they were all texts with the exception of the audio clip of "I Have a Dream."
Wow.
I couldn't find anything that said if there was a reason why they were focusing on text documents as far as writing or not.
I would assume that because text is the if you're encoding an audio file, you have to have a system that decodes it.
Yeah.
And text needs the least of that.
Yeah.
Pardon me.
Well, that would make sense. Yeah, sure. If it's the easiest, then that's what they're doing. Although they do
you
have the one audio clip.
Well, right. You have this audio clip, which is a waveform in the real world, but it has to be translated to some kind of data. You needed something that's going to untranslate that, and like that's the whole thing when we send stuff off like on Voyager and out into outer space for aliens to read about us or whatever. Right? We have to create the system that lets them also take in that data or observe that data.
Yeah.
You can't just put it out there as
it's like encrypting and decrypting. Yeah.
Sure. Well, that's and that's a thing that I know has been talked about sometimes when loss of data comes up, where people have talked about, well, if you recorded something on, say, what was it called, the tapes that Betamax used?
Beta cassette.
Is that what it is? A beta cassette, right?
Beta tapes.
I mean, if you had something on a beta tape, who has a Betamax anymore?
Yeah.
Or whoever had one. I don't know. I mean, that, right? I mean, so you can lose knowledge just because you can't read it anymore.
Yeah.
We had a thing when I was back in another lifetime when I was working for the Oprah show and we were editing there. They were still using beta tapes, and this is in the early 2000s. Ooh. However, most of the industry was because they were using digi-beta. They actually took the beta tapes and turned it into digital code. They just stored it on beta tapes because the accuracy of the magnetic code was so much, I guess, more correct or whatever on beta than obviously on VHS or other things. That I remember when I first started working there, I was like, "We're using beta? What's going on here? What is this?" And then it all came together, and really, it's just they were using the technology in a different way. But most of the industry was. It was fascinating.
Wow.
So beta, analog beta kind of died out. Digital beta stuck around for a long time.
Holy tamale! I had no idea.
Yeah, I know, like, so if you, crystals have come up in this because you can encode information there. And, I mean, if you're really into conspiracy theories, there's like theories that the crystal skulls actually have data in them and et cetera, but we just can't read it. But
but it's got all the.
When you try to read it, one of your eyes goes a little droopy.
I hate when that happens.
Then you wrestle a rubber snake, and then you fall down 3 waterfalls.
But I digress. So DNA, currently, aside from that, it's really slow to write and read. Also, even with, so I mentioned how a lot of errors occur when synthesizing, but by using the 4, that helps a lot.
It's really smart.
However, there is still a lot of error that just comes up with synthesizing data or DNA strands. So economically, using DNA is not very feasible right now because of all the errors and just because of the time and synthesizing DNA. But as the technology progresses, and if you also consider, the National Archives cost millions to store and keep climate controlled, et cetera, I could easily see this becoming reasonable, like within my lifetime.
I remember like in the 80s, you would have you kind of have your quick disks that you'd use on your computers, and then you'd have your hard storage. You put it on a tape, like a tape cassette. This is maybe even the 70s really, because the tape cassette was linear and you could only pull the data off the reels. So it was almost like what zip disks were for a while there in the 90s. He's like, you can't just pull off the zip, you have to unzip it, but you can compress it down. Yep. This is kind of like that philosophy where we can really store a lot, but we have to compress it, so to speak, by using this system, which is a great idea for archiving.
Right. For things you don't want to access every day, this is fine.
Yeah.
And we're getting a lot of data.
Yeah.
We are only going to have more and more. We, as in the human race.
Yeah.
It's getting crazy.
So, actually, we should break here, and then we're going to come back with the next jump, because it gets better than DNA.
It gets smaller than DNA.
It does.
That's
Indeed, it does.
bonkers.
It gets like almost quantum physics small. It's very exciting.
That's great.
So we'll see you in 10 seconds. All right. See you, baby. From TPN at Technophilespodcast.com, I'm David Geisler, and this is the Technophiles Podcast. All right, we are back from the break. I'm here with Vee Laabs, Krista-Lee Malone, and Jake Gill. And Krista-Lee, we are talking all about data storage.
Yes, we are.
We just had a very interesting
Data storage.
data storage.
You should have brought up a picture of data from the next generation.
I should have.
Just throw them in a closet.
Yeah, right.
Turn them on when you need them, right?
Yeah.
This is our data storage. Our data storage.
It's an episode about that.
Man, puns are the best. Also,
All
awkward
right.
silences.
All right.
Krista-Lee,
so,
What are we really talking
So
about?
we were
Right.
talking about data storage through DNA,
Right.
but DNA is pretty small, but things get smaller,
they are,
don't
but
they?
things do get smaller. So this story actually starts 5 years ago. 5 years ago, Wired had an article that reported IBM had managed to store 1 byte of data. Now I'm wondering, bit, byte, data?
Well, bit and byte is two different things.
This is
But it's okay.
BYT.
This is a byte.
Yes.
1 byte
Yeah.
of data
Yes. I
on
know.
12 atoms.
But the words are too close. I confuse them. Anyways, yeah,
Okay.
so 1 byte of data on 12 atoms.
Mm-hmm.
But
And they did this by arranging them in opposite directions, which keeps the atoms from interfering with each other. So one of the problems with atomic data storage is one, when atoms get too close to each other, they can affect each other, which can change things. And
Yeah.
then also being able to read an individual
Adam.
atom or the data on the atom without reading more all at once, basically, like being able to read it as a distinct unit.
Our observation tool has to be so
Yes.
small.
yeah.
All right. But by arranging the 12 atoms in opposite directions, this solved, mostly the interfering, but then it also helped with the closeness for the reading device. And yeah, this was a huge breakthrough, especially considering that the biggest problem that we have had at this time was we didn't know how to keep a stable magnetic state at the quantum level.
Right.
So that was the other thing. By using 12 and putting them opposite, it helped stabilize it for a little bit. And this was as small as they could go, because otherwise the fields just became completely unstable, and it would be like a crapshoot of what you were going to get.
They store one byte of data, which means they didn't create the opportunity to store 1 byte. They put data on that, right? I assume.
Yes, and they could put it out. They could read it, and then they could
Put something
They
there.
could write it and read it.
Yep. Good. Cool.
All right.
Not just like, hey, we could put stuff here.
Yeah, no. They actually
Excellent,
did
excellent.
this. And this is, there it is. There's the picture.
Yeah, we have it up on our
Then-
YouTube video right now.
That's right. I forget that sometimes it's not just YouTube. Anyways, now last week,
It's mostly not YouTube. Most of our audience does not watch us on YouTube right now. Like 95% of our audience listens to us. But they're welcome to go over to YouTube to see this picture.
Yeah. Come see our
Anyways,
beautiful faces.
so then last week, also IBM writes 1 bit to 1 atom.
Yep.
And this is actually huge. It took them 5 years to go from 12 to 1, but it was huge.
How do you even do that?
How do you create your 1 and 0?
Yeah, with an
I think you
Just
make it spin
one.
one way or another, kind of like polarity, kind of like magnets.
Yes.
yeah.
Yep. Yeah, basically. Previous experiments with storing data on atoms required you to move the atoms around. So what you did is it was based on like the location of the atom. And
Ping
this
pong
was-
balls and plastic cups, I'm telling you.
I mean, basically,
serious.
but it was hugely inconvenient. Basically, IBM is using. Actually, that's what David just said. Yes, magnetic storage.
I'm sorry. I didn't mean to. I didn't read your notes here.
That's
I
fine. It's
apologize.
fine. It's just like I started saying that note, and
Yeah.
then I realized like I'm just going to repeat what David
So,
said.
like, if you
But
thi-
there
yeah.
you go.
David, you were right.
You were right. There you go. Okay.
Well, the spin is
so,
very exciting.
The atom they used was a holmium atom, which is it's a rare mineral found in Earth.
Holmium. Don't know anything about
Couldn't
it.
they use like a
That's a new one to
less
me.
rare thing?
Well, I wonder why. Maybe it's really stable from like its nucleus or its
No,
electrons.
I'm
or
sure they have a reason for it.
Yeah, so holmium can be magnetized in the way they need. Whether or not something else would be possible, I'm not sure, and they didn't say.
I'm sure that IBM has a reason for it.
Right. They
Yep.
basically they just said this is what worked best at the moment. So there you go.
Okay. Well, yeah.
Plus, we're also even if it's rare, we're talking about a single atom of this thing.
Yeah.
I mean, at this level, like you kind of just holding this stuff in place with magnetic polarities. I think. In general, no. I mean, how do you keep that atom there? You know what I mean? Like, I think it's really broad strokes here, but you're kind of just using magnetic polarities. So maybe this thing's really magnetic. We'll just
Yeah.
say, right?
I mean,
Like,
it is.
Maybe that's why they go with it.
And that's how they're
Yeah.
using it to write the data. But I actually didn't think about how they actually kept the atom in place. That was not discussed
A
in
box.
the article. I mean, box,
Teeny,
sure.
tiny tweezers.
All right, so now space still becomes an issue as far as atoms being too close to each other and interfering with each other. So that problem hasn't necessarily gone away, but IBM says that this using the holmium atom, it can work as close as 1 nanometer space in between individual atoms, and if it's that far away, they won't interfere, and they can actually read it as distinct units. Just as a comparison, it takes roughly 100,000 atoms to store 1 bit of data if you're looking at like regular storage.
Yeah, an element, a magnetic
Yeah.
element.
Yeah.
Now, to read the
That's
data...
a significant improvement.
Yeah.
Yeah.
Right. To read the data, they also use a single atom. They use a single iron atom,
This is fascinating.
What?
and it measures the flow of magnetism from the holmium atom.
So holmium, I just pulled it up here real quick on Google. It's a rare earth element.
Yeah.
So and then they're using iron, which obviously has a lot of magnetic properties.
Yes. Yep.
This is so crazy.
This is insane.
Yes. Unfortunately, at the moment, this is not commercially viable at all. It required a ton of lab equipment and vacuums and large machines and a lot of money and
Right.
you
Whatever.
know,
Well,
like you do when
back
you're in a lab.
the 1960s, 16 kilobits was an entire house or
Right,
whatever.
right,
Yeah.
right. So that's the scale that we're at, which I found it amusing because we're talking about writing on a single atom, and it requires an entire room full of lab equipment to do this. So that's where we are, but still exciting.
Holmium is also, as I read here, will react with water and corrodes readily, and also burns if the air is too hot.
Dang
like,
it.
on its own.
So we're gonna need some
Seems
nice
kind of like a
environmental
particular.
conditions.
I see
Yeah.
a Library of Alexandria moment coming
Yeah.
in our future.
No! Our atom storage. Ah, darn it.
Oh no.
All those atom emails lost.
Okay, yeah. So that of course brings us back, full circle to David asked me in the beginning, "Hey, why did you think of it?" And it was because I found this, writing a bit of data on a holmium atom. But, and this is where we're gonna jump to 2,000 years ago.
Whoa. That's
What?
right. I forgot.
Yeah, we
I'm
are.
excited.
So I'm bringing this back over to anthropology and history here. So aside from the obvious, you have to be able to store things, otherwise your computer's not going to work, the programs, et cetera, data storage can do a lot for a lot of other disciplines. So the example I wanted to bring in was the Dead Sea Scrolls.
Okay.
Aside from being a technophile, I am really into history. So I've actually read quite a bit on the
So you
Dead
just look in both directions.
I
Anyway.
really do. I really
Learn
like.
a lot from the past.
Yes.
Yep,
Yes.
absolutely.
So I've read quite a bit on the Dead Sea Scrolls. I find them fascinating. I'll give you a little background, but trust me, we're coming straight back to data storage.
Cool.
The Dead Sea Scrolls were found in the Judean desert. The first batch was found in 1947 by a Bedouin shepherd. And it's basically a whole cache of ancient, mostly religious texts, although they're not all religious texts. They're like copies of biblical books and Jewish writings from like first century. And yeah, they found these. Of course, being found in 1947 and being taken out of the dry desert atmosphere, which was allowing them to be preserved, they started getting really damaged.
The lack of moisture was what was keeping them mummified-ish.
Yeah.
I mean, seriously.
I mean, really, that is what it was. So even just bringing them out, a lot of them got damaged. And then, I mean, they weren't in pristine condition anyways, right? So now you have these fragments of these texts that are just, invaluable to the Western world, right? And they're in pieces. So people are trying to put them together like a puzzle, but in moving it, now you're damaging it more. And you also really don't want people even touching them, and you don't want a lot of people coming in. I mean, this is all very bad.
I think I see where this is going.
You really want this to not be touched. So they eventually, over time, digitized all of the pieces, and now you can have, anybody working on this, right? Because they're not all pieced together either. So
in
now
what way were they digitized? They're optical, like they're images, they're 3-dimensional scans. What do you think?
They're mostly images,
mostly photographs, essentially.
Yeah, basically. They originally back in the oh my god, no, I forgot the word again. So
National
they actually
Library of
the National Library, obviously. No, the
National Archive.
National Archive. Even I forgot just now.
It's too easy.
It's the blandest name of anything ever.
Anyway. Back before everyone had like internet and stuff, they were actually like trying to take like photographs and scans and types of things. But they were also back then taking actual pieces and sometimes trying to tape them together. Yeah, I know. It's just like,
well, no, they were using the special library tape, the opaque tape.
Still don't. Still don't.
The non-gloss tape.
Right.
No.
But yeah,
they were wearing gloves.
But now with the digitization, right? Yeah. Because you still want to be able to put the pieces together and see what these are. So yes. So now you have all of these up online, stored in the cloud, and they can be shared with researchers, anywhere. And you can sit there and it's just like playing like a digital jigsaw puzzle you can download for free, right? And like, here, put the Dead Sea Scrolls together.
I start to wonder why do they have humans doing this? Let's give this to DeepMind and let it just go.
So actually, that is a great idea. You know what else I thought of? Which if somebody listens, you need to do this. Remember that game Folded?
Yeah.
You can make this into a puzzle game and throw it out. I mean, because if you think about it,
give them a key of I think it's Hebrew. It's written in.
It depends. There's Hebrew, Greek, and Aramaic.
So, Folded was a game for the mass. Can you explain it real quick?
Yeah,
we've talked about it many times.
Basically, you fold proteins to see something that works, and scientists created this little game, gave it to the masses, and it's kind of human computer, like from 3 Body Problem. You have all of these humans working on this puzzle, and then you're finding
and there were some big breakthroughs,
right?
A lot of people were working on it together.
Yep.
Right.
Something that would have taken years upon years to do was done in less years.
I mean, that's what we need, like the Dead Sea Scrolls game.
Yeah, why not put all the pieces?
Krista-Lee, I think we just found your new career.
That's it.
There you go. Just
there it is.
Gamifying science to get things done faster.
Even if you don't read any of those 3 languages, because let's face it, there's probably not a lot of people on the planet that speak these ancient languages, right?
But it's all patterns.
Exactly. You have patterns, you have the tearing on the side of the pages. I mean, there's still, I bet you they would still come in with some breakthroughs just putting the pieces together.
Yeah.
The more you say it, though, I'm with David. Give it to DeepMind.
DeepMind it, yeah.
Just DeepMind it. That's gonna be how humans end, because we're just gonna say just DeepMind it. Just
give it to an AI.
Dump it in DeepMind.
Give it to an AI. I mean, that's our.
I gotta go work on my tan.
What is it? 20 years from now or whatever? Who knows?
Go eat 20 Snickers bars.
We can go pursue other things. But I mean, I don't know. Yeah, maybe we don't want to give everything to an AI, but if an AI could do millions of iterations, or billion, whatever, over, it's going to be significantly faster.
This seems clearly like a good
humans.
use of that tool.
But it's Yeah. Digitize, and then we're preserving the ancient thing.
Yeah.
And we're able to manipulate it in new ways because it has been digitized.
Yeah.
One other thing that
Which is
DeepMind
super
might be
cool.
able to do is deduce holes. Not deduce where a hole is, but where a hole is based on all the patterns. It could try to deduce what would be there.
Yeah.
If there's
There-
a pattern to the language, obviously.
There are
I mean,
literal holes in
Yeah,
the
there
scrolls.
are.
V has a thing up right
Yeah,
now.
yeah.
Well, there are whole conspiracies around that because they're like there's the whole thing about how it says, it's like blah blah blah, and then Jesus kissed her on and there's a hole right there. Right?
Oh,
Yeah.
come on. That's 14-year-old logic. Or I'm a 14-year-old. Or let's just keep talking.
This is
No.
an actual thing because this comes in the question of there's like some people debate whether or not Jesus was married, and the idea is the word mouth
It's
fits in that
the
hole.
Da Vinci Code.
Right, it
Got
is
it,
the
got
Da
it,
Vinci
got it.
Code, right? But also we were talking about a region where it's not really uncommon to like kiss in greeting, so it could be like, she walked in, he kissed her on the cheek, right? Because this is how you greet. I mean,
Yeah.
it's not necessarily a conspiracy, right? But
Yeah.
just as a point of yes, there are places where there's holes like this, and people are already debating what goes in these holes.
Yeah.
Got it.
But I'm not sure.
That's a separate game, though.
If
Yeah.
DeepMind, it is. I'm not sure
That's
if
a
DeepMind's
historical
there
game.
yet
All I
with
meant
human
was
language.
all I meant was
No,
it's not that we would 100% trust the deductions, but if
Sure.
anything's going to deduce what could be there, I feel like it's a pattern recognition AI.
Yeah.
Machine learning, right? Tea leaves, except it works.
It's right.
Just constantly iterate until something clicks.
Yeah.
No, I mean, this is fascinating.
Yeah.
Just the fact that can happen. And so yeah, I don't know.
Yeah. So and I brought up the Dead Sea Scrolls, like I said, because it's just my own little thing that I like reading about. But you could fill in the blank any old manuscript, artifact, whatever that people would want to study, but that you don't want to damage, and we can do it. We even with like the 3D scanning and everything, it doesn't have to be just text that we're talking about. You can
So that data,
scan artifacts and then have that data, and you can store it now and share it.
I imagine that the images of this stuff isn't one thing that's not exactly lined up is like it's not like it's millions and billions and trillions of gigabytes to store the Dead Sea Scroll
Right.
data. But like we do have this stuff where if you have a Google app on any of your devices, you're this is not conspiracy. Like Google says, we know this. We did articles on this. We've done episodes on this. Like it records everywhere you go and deduces. That's how when you like search a restaurant or a store on Google and it gives you the if it's busy or not there. That's a combination of deductions of past data, but it's also big data knowing I had so many phones in that area. You know what I mean? That's okay. A person doesn't freak me out. But here's the thing about that, if I may. Google still stores all of that as well. You can retroactively go back and look at that data. You can look at your own personal data, which Google offers.
Well, of course, because you can't have trends
Scanning
without
every
the data.
book that's ever been written is fantastic and awesome. But like, just think about the exponential rate that every millisecond of every single person's life who has a phone right now, data is being recorded.
Yep.
This
Yeah.
is going to build up fast.
Well, sure.
And I think that's wonderful, but it's a big deal.
It's a lot.
I mean, sure, that goes back to the 44 trillion gigabyte estimate by 2020, right?
And so then eventually what we're doing is I'm making a joke here, but then you're zipping 2010, you're zip compressing it down to your DNA strand and they store it and whatever. And, 100 years later, we still have it in our archives and we know where every single person walked and what store they went to in 2010. And I'm still kind of on the side of that's not necessarily a bad thing. I think it could be very interesting. I think that's something to think about here too when we're talking about large, massive amounts of data
Sure.
storage.
When it comes to personal data, actually, if you looked at something like the DNA storage, I almost feel like I would feel safer because it's not something that's easily accessible. So I feel like if somebody is going to want to know so badly where I was on a certain day that they're going to go through the trouble of reading that DNA strand
Yeah.
where it is,
Right.
then
And the reality of
Yeah.
someone 50 years from now unzipping a DNA package to know where Krista-Lee was on Wednesday and in 2017,
Right.
I think that's it's conceivable, but I think it's not really about that. It's really more about future artificial intelligence software knowing where 20 million people were on a Wednesday in 2010.
Oh, yeah.
You know what I mean? I
Yeah.
think it's more
Of
about
course.
that.
The trends.
I'm not that worried about AI, I don't know. You see where I'm going with this? I think
Sure.
it's really
Yeah.
those numbers become, it's large numbers. It
Right.
becomes really big numbers.
And we just need to figure out the best, most efficient ways to store more and more and more data because it's not going to slow down.
And so the answer to storing large amounts of data is making the storage medium smaller,
Yep.
which is what you've been talking about all night.
That's
Yep.
when we get atomic.
But for research and whatnot, you're going to want something more easily accessible than something like DNA. So
That's a good point.
Because
Yeah.
like there's a huge push in museum studies right now to have digital collections of everything so that it can be retrievable 50, 100 years from now or whatnot, right? Because stuff breaks down. But
Oh,
you
yeah.
don't want that on DNA. You want that. I mean, most of those projects they want them up online so that you
Yeah.
can visit the museum without visiting the museum.
Maybe
Yeah.
that's atomic eventually. Maybe that's like, this quantum computer.
I mean, for right now,
Yeah.
it doesn't make sense.
Right. But eventually it might.
Yeah.
Well, like,
Things
I think it is
deteriorate.
interesting to note, though, because we're just talking about like storage and accessibility and stuff. And I mean, at least for the immediate future, it does seem like cloud is cloud is fantastic because it is. I mean, maybe it's on someone else's computer, but not really. It's it's in server farms and there might be actually backups in other places. So you're kind of like your data is safe in the sense that like it's all over the world.
Well, and that's what it is. And certainly that's why I enjoy the joke of it's just on someone else's computer, because it's like, well, because for the person who might be going to the website that you talked about in the beginning of this episode, they say, what is the cloud? Oh, it's this magical thing. You know what I mean? It's a metaphor.
Well,
But essentially what the cloud does is it turns the whole globe into a computer. It's really
Yeah.
interesting.
And all the satellites in orbit and,
Yeah.
when we're not. Yeah, go ahead, Krista.
no,
I'm
I was
sorry.
going to say, but like, I actually really like the analogy of it's somebody else's computer because sometimes by not understanding how something works, a person will run into problems in using this. So
Yeah.
I actually ran into this problem with my class this semester. They're making these Twine games, and the way Twine visually looks on the user interface, this will only take a second to explain.
And you've spoken about Twine in the past.
Yeah,
but could you tell us
we
what it is?
have. So it's basically a hypertext game / interactive narrative, and I'm basically making my students all make a game using Twine as their final project.
It's a little bit flowchart, a little bit choose your own adventure.
Yeah,
that kind of thing.
exactly.
Yeah.
And what one of my students did is they had a local copy on their computer, and because Twine looks like a web browser, they went and copied copied the location, sent it to me, trying to turn it in.
And they didn't realize that file was local on their computer.
Exactly, because visually, because if you don't,
I'm sorry, you do access it
understand-
in a browser, don't you?
Yes, you
Yeah.
do. But again, because the student didn't understand entirely cloud storage and the internet, they thought that this would work, and of course it didn't. And I gave a mini lesson on how cloud storage and the internet works. But people talk like this a lot of times. I've heard people describe the cloud as, well, it's stored on the internet, and they're like,
Right.
well. I'm like, okay, and where do you think the internet is?
Well, that's kind of
Yeah.
the joke. That's like the best part is, we speak of the internet as it's a thing.
right.
It
but
reminds me of the IT
The IT
crowd
crowd.
episode with the red
This
light.
is the internet.
And it might as well be. Like, it's so
Right.
silly.
Right. But there are, I run into people who don't actually fully grasp that. Like, they actually do think that the internet is, there is
Like a
one
place.
central place. Like,
Yeah.
this is the internet.
No.
And we all just go and access it.
Everywhere's the internet. We're all around the world. It's a big old web.
Well, even the expression of the cloud started as almost like an in-joke over in California. You would hear programmers just say, and then we send it to, the cloud or whatever, because it goes
Sure.
up into satellites or whatever.
Yeah.
And it was just kind of a joke. And then I remember after a couple years, someone would say it at an Apple keynote, and then someone over at Microsoft would say the cloud, and all of a
That
sudden,
etymology
I
just-
kind of people just said, "Oh, okay, I guess let's brand this as that, as the cloud." But it helps you visualize it, but it may accidentally help you visualize it too much,
Yeah.
like in the case of this student.
Especially with the growth of Wi-Fi, where it's the internet's in the air and it's being transmitted wirelessly. So it's I guess it's in the air now. Up in the cloud.
Yeah.
Yeah, that's part of that
Interesting.
etymology.
Well, we have
Metaphor.
maybe 1 or 2 minutes left here, so we do have some time for some closing comments and stuff like that, Krista-Lee.
Yeah, I don't know. I kind of expected the Dead Sea Scrolls to be my closing.
I know. We still
it
had
was-
10 minutes to burn at that point.
Yeah, I went through the history a lot faster than I expected
It's
to.
okay.
But yeah, I was really excited about this. I'm really excited that I can read snippets of the Dead Sea Scrolls on the internet because it's been digitized, right? Because this is the type of thing that before this technology, this is the type of thing that would have been behind lock and key in some vault somewhere, and I never would have seen it, and that would have been the end of it.
Only top scholars would be
Right.
able to see it, you know.
Right, exactly. But now just having that access, and that access is available because of our storage, basically.
Yeah.
I can't help but think about the DNA thing, where I'm very curious about what is the machine, the hardware that writes and reads that data onto the DNA. I think a lot of it is chemical, to be quite frank.
Yeah.
But so to speak, what is the hardware?
Yeah.
Because then you start thinking in 5 or 10 years or 20 years or whatever, conceivably at a time where this is being stored in DNA, like, now where does that DNA get stored? Is it just a couple vials in some building somewhere? Can people inject it into their arm and then you harvest it later to do espionage and stuff? Like, I'm serious.
It's that whole thing of like, when does it become practical? Like, data storage went through the whole evolution of like getting smaller and smaller and smaller and more practical to like be accessed anytime, anywhere. I guess with DNA, it's going to become like, how do you read it with machinery? When does the machinery to read DNA get smaller? When does the machinery to write DNA get smaller?
That's true. And obviously right now the trajectory is that this is a global solution, meaning that they're not expecting every single person to have their DNA reader and writer,
Right.
I think.
Right.
This
So-
is more like a national global thing.
So one thing going on that I didn't mention because I didn't think we'd have time is one of the benefits that some scientists are touting about DNA is that because DNA is so universal, the expectation is that even if you had an alien civilization or civilization collapse or whatever, that technology would eventually come back to a point where you'd be able to read DNA again because it's so universal that, of course, people would work toward the ability to read DNA.
That's interesting. That's interesting, yeah.
That's
Well, it
like,
seems. I mean, we're able to extract a lot of genetic information from things that we're finding that are way more than 2,000 years old. So it's
Yeah.
like, it seems like the shelf life of something like DNA is incredibly long term as well, which is another benefit.
Yeah.
yeah.
So
Maybe that's the way this goes is DNA becomes our hard storage, our way to compress things, and maybe this atomic stuff is what's going to move our fast stuff.
It's a circle of data
next thing.
storage.
yeah.
Whatever. If we had to try to sum this up. But anyway, that was wonderful. Thank you very much, Krista-Lee, for bringing that topic to us. Let's see, if people want to tweet with you about it specifically, they can find you on Twitter.
At GamerAnthro.
Marvelous. And then we've got Jake. We have you with your Sideways Dictionary story. And if people want to chat with you about that on Twitter, they can find you
At Critical Owl.
at Critical Owl. Vee, the black hole situation, if there's any follow-up information on that or people
Yeah.
have some ideas about it.
If they want to tweet me about or gripe to me about anything else that sucks, they can tweet me at bear_Annika.
I'm going to put a pun jar on the 2 or 3 of them is
Gonna
too
hear
many
like
in an episode
clinks
for my
throughout the
taste.
podcast.
No, it's all good. That's funny. That's fine. All right, excellent. So let's see. I think we're back next week. I don't know who's. I think it might be you, Jake. Is it? It doesn't matter right now. It might be V. I can't remember. I have to look at the.
remember. Yeah.
I have to
I
look at
was
the schedule.
last week.
Yeah, it's
so
gotta
it's
be
probably
V.
not me.
Probably
Yeah,
V,
it's
and then I think
probably
it's me going around the circle here. But V, it'll be exciting for you because we're doing the newscast with you this weekend.
Yeah.
Do you have any ideas of what you're going to talk about, V?
For the newscast or
No,
my
for next
main
week.
topic? Oh, I have no idea.
Okay. That's okay.
I always figured out.
Maybe we'll find some more planets.
Oh boy, fingers crossed.